Hello class, welcome to today's lesson in which we're gonna keep on talking about conversion of units. But now we're gonna do this in the context of application problems, what you usually understand as problemas razonados. I don't like that phrase too much because I consider that every problem should be reasoned, right? But that's just me. Okay, so we're gonna be solving activity 2 from page 19 from our book, and it's 10 problems. It's 10 problems within this activity. I'm going to be helping you and giving you an outline on how to do these problems by solving two of those, problem number 5 and problem number 9. I'm solving these two because in my experience, these are the ones that usually have a lot of, the students get a lot of confusion in these two particular problems. Okay, so let's get started. Here we go. So problem number 5 says, determine the number of atoms in a sample of 0.7 grams of pure uranium if the mass of a uranium atom is this much, 4 times 10 to the minus 25 kilograms. Okay, so we need the number of atoms in a sample. What is a sample? Es una muestra. It's just a little bit of uranium. Okay, so you have a little sample, you know, of this element. Here is your sample, and you want to find the number of atoms in such sample. What is the number of atoms? So let's label this number as n, and I need to find n. Perfect. What else do I know about the sample? I know the mass of the sample, which I'm going to write as ms. The mass of the sample is 0.7 grams. Okay, which is, I mean, you can either write it as 0.7 grams with the full word or with the symbol 0.7 g. Okay, fine. What else do I know? I know the mass of the sample. Perfect. And they also give me the mass of a single uranium atom, which is this much. This is a very tiny quantity. So I'm going to represent an atom by this little dot, and I know the mass of a single atom of uranium, and it's this much, 4 times 10 to the minus 25 kilograms. Okay, so how do I solve this problem, guys? Basically, all you need to do is divide the whole mass of the sample, which is this much, over the mass of a single atom, right? That's all you have to do. It's a very arithmetically speaking, it's a very simple problem. If you have all of this sample and there are many atoms in there, how do you know how many number of atoms you have? You divide the mass of the whole thing over the mass of a single atom, and that will tell you n. So I need to divide ms over ma, which is equal to this, 0.7 grams over 4 times 10 to the minus 25 kilograms. But don't make the mistake, guys, of doing this operation directly, because you're having different units, grams and kilograms, and you cannot do operations, arithmetic operations, if you have distinct units. That's why we need the concept of conversion of units. I need to convert either grams, either this quantity into kilograms, so that it matches this one, or vice versa. I need to convert this into grams so that it matches the other. Okay, which one is better? It doesn't make any difference. So I'm gonna convert this to kilograms by the process that we already know. We're gonna write the quantity. We're gonna draw this type of structure or table, and I'm gonna write the conversion factor in here. So do I know the equivalence? Yes, I know that 1,000 grams is 1 kilogram, right? And out of this equivalence, I will get the conversion factor. The grams should be in here, the kilograms should be on top, and that's it. Multiply this times this times this times this, and this times this times this. But let's first cancel the unit that we wanted to cancel, this and this, and then at the end you will have that all the process will give you this number, 0.0007 kilograms. Okay, so there you go. 0.7 grams is equal to this many kilograms. Okay, and now you can proceed to perform the operation like so. You see, this is the calculation that you need to perform. Now the units are equal, so we can actually go ahead. Kilograms cancels kilograms, right? Because equal factors up and below. And now all you have to do is make this division of this number over this number. So grab your calculator. I'm gonna grab one, and let's just proceed with that operation, please. Give me a moment because I'm having trouble with my calculator. I'm gonna stop the video. I'm having some trouble with my calculator. It's not turning on. Just wait. Thank you guys. I'm back, and I already did the calculation, and I'm gonna write the answer in blue. I got 1.75 times 10 to the 21. It's a big number. It's supposed to be a big number, right? Because I mean, we're talking about atoms. If you have a sample of atoms of some element, in this case uranium, yeah, you're supposed to have a lot of atoms in there. Okay, if the size of the sample is considerable. Okay, so there you go. That's how you solve this type of problems. You first make a conversion of units before you actually solve the arithmetical problem. What about problem number 9? It goes like this. In a paper factory, a roller rolls up newspaper paper with a speed of 18 kilometers per hour. And the question is, how many meters of paper will it roll in a second? So it's just basically a conversion of units, right? We need to transform this quantity into meters per second. And don't get too hooked up on the statement of the problem. Basically, what they have is this: it's like a machine producing paper, right? Like one of those machines that produces paper, a sheet of paper, a continuous sheet of paper, right? This is a machine, and this is the paper, and then they cut each of the newspapers. This is one newspaper, another one, and so on. So this machine produces a very large sheet of paper in a continuous way. At what speed? At this many kilometers per hour. In 1 hour, you're gonna have 18 kilometers of paper, like so. And all they're asking you is basically how many meters of paper. Meters will it roll in 1 second? So I just need to transform this quantity into meters per second, and that's it, guys. So let's do it. You already know how to do this. 18 kilometers, we draw the structure per hour, and we multiply by convenient conversion factors. I need meters. I need to cancel kilometers, and I need to get meters. So I know that the equivalence is this one. 1 kilometer equals 1,000 meters, and I'm going to write this as a conversion factor in here. 1 kilometer, 1,000 meters. This conversion factor will allow me to cancel this one. And the other conversion factor should be between hours and seconds. And I know that 1 hour equals 3,600 seconds. And let's write this here on top. I need to write the hour here so that it cancels this one. Perfect. So that's it. I cancel the units that I wanted to cancel: kilometer, kilometer, hour, hour, and the rest is just uh, an arithmetical operation. 18 times 1,000 times meters, you're gonna get 18,000 meters, right? And then 1 times 3600 times seconds. So you will get this, and then divide this number over this one. So let's do that. 18,000 over 3600, and you're gonna get 5 meters per second. This meter and this second, like this. This is the answer, and that's it, guys. So I mean, this is no different from what we have been doing about conversion of units, right? It's just that they will give you uh, some sort of context, some sort of problem, and basically in the end, in order to solve this problem, you have to make some conversion of units, like I have shown you in these two examples. That's it. So let's do the rest of them, guys. I want you to finish all of them in this lesson. It's completely achievable in one lesson, and that's about it. Okay, thank you so much.